All right, welcome to today's video. We are talking about plate boundaries and hotspots. So we're going to break it up into different categories. First, we have the convergent boundaries, and these boundaries are moving together. Divergent boundaries move apart from each other. Transform boundaries are moving kind of parallel to each other, sliding past each other. And then hotspots is a different category that we'll get to, but it forms very similar things as these boundaries. Okay, so I decided to pick key locations that hopefully you'll be familiar with. The first one is right here where we are at George Fox University. In the Pacific Northwest, we have the Cascade Mountains, and a very famous mountain is Mount St. Helens, which blew its top back in the 80s, and that's what we're going to focus on right here. So what happens here is that we have an oceanic boundary, an oceanic plate that is converging with a continental plate. When they come together, they're going to collide, but the oceanic plate is more dense. And so what happens is that it will go ahead and subduct. So this is called subduction when the plate goes down into the mantle. And then this is the continental plate, which is more buoyant. So it's going to stay up. As it's grinding past each other, sediments, micronutrients, rocks are breaking off, and we have this what's called a wedge of accretion. Accretion is Latin for to build or to accumulate. So we have all this accumulation that's going on right here, and that's new continent. It's kind of binding the continents together. Another thing that's happening is that as it goes down into the mantle, it's experiencing higher temperatures and higher pressures. So water that's in this rock is going to be forced out of it due to the high pressures, and it's going to go up. And what happens is that this water that's being introduced here is causing the melting point of the rock to lower. So when we have a lower melting point, the rock is going to melt and it's going to turn into magma. So the magma also is going to be going up because it is less dense, more buoyant. So we have this buildup of water and magma, and it's forming very, very high pressures. Another thing that's happening is as these continents are colliding, they're kind of bunching up and forming these mountain ranges. So let's just say this is Mount St. Helens right here. Okay, so magma is coming up through these mountains, and all this pressure is building up, and eventually it comes up through and forms a volcano. All right, so let's summarize the convergent boundary. That is an Oceanic-Continental boundary. We have volcanoes. We have earthquakes, of course, because the land is moving. The volcanoes here are very explosive because of that high hydrostatic pressure from the water. Okay, we also have this way that magma is forming due to the lowered melting point because of the introduction of the water. That is called flux melting. There's different ways that magma can form. Let's go ahead and move on to the Marianas Trench. I chose that because it's pretty popular. It's in a lot of sci-fi movies, and that's where the Meg lived. That's where it came from, and forms a really unique ecosystem as well. So we have two oceanic plates coming together. We also have subduction because the older oceanic plate, which is more dense, because more time has passed, so sediments can build up on it, causing it to be heavier, more dense. Gravity is going to pull on it to go down into the mantle. And so very similar things happen here. Again, we have the water that's being forced out of the rock as it goes down into the hotter mantle. We also have magma forming, so we have flux melting going on as well. that's going to make its way up, and we're going to have little underwater volcanoes. It's not going to be quite as explosive because they're underwater. And let's see what else is happening here. Oh, as it's subducting, of course, it's going to be forming this huge trench, just a very, very deep trench. And that's why the Marianas Trench is so deep. It's the deepest part of the ocean that we know of. We have hydrothermal vents, we have sulfur vents going on, and that creates a unique ecosystem with organisms that are really uniquely adapted to this environment. Okay, so we have similar things here. We have underwater volcanoes, maybe not quite as explosive. We're going to have earthquakes down there. Also, I'm going to go ahead and add tsunamis, because if the water gets displaced, then it could cause huge waves forming tsunamis. Flux melting is going on as well. So I'm just going to move those over because they're very similar, only it's happening in the water. Okay, so let's move over to the Swiss Alps. I had a chance to visit Switzerland last year and saw the Matterhorn, the real one, not just the one at Disneyland. And so this is two plates that are continental plates. They're of equal buoyancy and density, so they're just going to keep crashing into each other. So what we see here are just huge, jagged mountains that are forming as these continental plates are colliding, and they're very pointy. So let's say that's the Matterhorn right there. Okay, so these continents are forming together. They're grinding together. We'll also have some accretion as well, right? Because they're kind of being cemented together. But one is not subducting, so we're not going to really have a lot of volcanic activity. So mainly we're going to have a lot of earthquakes. We're going to have big mountains forming, and that's pretty much what's going on here. Okay. Mount Everest is also another great example of this in the Himalayas. Okay, so that's convergent boundaries. We have three different kinds: Oceanic-Continental, Oceanic-Oceanic, and Continental-Continental.